all things have an end, and somehow more interesting things tend to end more quickly. Now we're at the end of this course, so let me summarize a bit what this course has been about and where you can go from here. So the idea and the intention of this course, not surprisingly, has been to give an introduction to graph theory and its applications. Equally so, it has been intended to provide a concrete framework for abstract mathematical reasoning, because graphs are something you can draw very concretely in pictures, and yet we've had abstract concepts like duality and isomorphism, homeomorphism, and all that, and it's more handy to see them in connection to graph theory than in other connections where you might not have pictures that help you visualize the concepts. Also, hopefully, this course has increased your interest in the neighboring areas of mathematics, those that are close to graph theory. And indeed, there are lots of places where you can go from graph theory. Graph theory touches upon many, many subjects, and already in this short course, we have looked into ideas from various other disciplines. So let me give you a few hints or a lookout to where to go from here. So if you felt that anything geometric interested you, like the shapes of graphs, things like planarity, drawing graphs on surfaces, contracting graphs, dealing with homeomorphisms, all of this falls into the general framework known as topology in mathematics. This is the study of shapes without regard to precise measurements, just the abstract and general study of shapes. So you might want to take a course in topology next. If you were especially fond of the parts where we counted things and asked ourselves in how many ways can you color this graph, in how many ways can you build this directed tree or whatever, then all of the questions that have to do with counting and asking in how many ways can I do something like this, they are related to combinatorics, and they're a part of combinatorics. So you might want to take a course in combinatorics next. If, like me, you love this idea of structure, isomorphism, duality, and abstract relations that give you somehow the, how should I say this, the backbone of the theory and the theoretical structure, and the structural, not geometric, not numerical, but structural similarities and differences between objects, then courses in higher algebra or abstract algebra might be something that interests you. If you are interested in graph theory itself and want to know how far has graph theory come today, most of the theorems I have cited in this course and we've been looking at date from at least 40 years ago, but of course there is graph theory being done now. And one area among many, this is not the only one, and I'm not an expert, but one area is that of random graphs. Random graphs are studied in probability theory. A random graph, roughly speaking, is a graph where, say, you have two nodes and then you toss a coin, and if you get heads, you put an edge. If you get tails, you don't put an edge. So they describe stochastic phenomena that you can model with graphs. For example, epidemic spread. If you have two people, then these people may or may not infect each other with the disease. There might be a probability P that they will. And so then you put an edge with probability P. And with these random graphs, there are many fascinating results that people are reaching, and active research is ongoing. So take a look online, search for random graphs, and you will find things that will interest you. If you're interested in applications, you can look at modeling in biology, as we have seen in the lectures and in the guest lecture, or in data science, or in any other fields of science and social science. You will find applications of graph theory, where you use graph theory and modeling to represent any situation where you have any sort of network or connections or anything like that. And if you are interested in anything else, then you have plenty to go into. Mathematics is infinite. It has a huge number of applications, and I hope that you will enjoy exploring it to the best of your liking. Thank you very much for following this course, and I wish you all the best.